So scalars and vectors it's a very important topic. So let's jump right into it. So scalar quantities. What are scalar quantities? Okay, scalar quantities have only a magnitude. Okay, magnitude. That's so examples of scalar quantities are just distance, speed, mass, just to name a few. Let's compare that with vector quantities. What are vector quantities? Vector quantities have both magnitude and direction. Okay, example are your displacement, velocity, and weight, just to name a few. So when we say magnitude, that's just a size, a value. Okay, so let me recap. Distance is a scalar quantity because with distance we're just interested in the size, the magnitude. But displacement is a vector quantity because we are interested in both the magnitude and then the direction. So with distance we just say maybe 5 kilometers, but with displacement we say 5 kilometers in a specified direction, maybe 5 kilometers northeast or 5 kilometers southwest. So let's look at this diagram of a journey of a man. This is starting point of the man, point A. It goes 3 meters northwards to point B. From point B it moves 4 meters eastwards. Okay, so this is his end point. Okay, so this diagram shows the movement of the man's journey. Okay, so in figure 1, the total distance between starting and end points. This is point A, is the starting point where the man starts up from. Okay, and his end point, this is end point. It started from A, went 3 meters north, then 4 meters east. So this is his end point. So the total distance we have to go like this, that is 3 plus 4. So we have to traverse every corner. So distance goes like this. Okay, so that's 3 plus 4. So the distance is 7 meters, 3 meters, then 4 meters. That's 7 meters. But the displacement is a different matter. Displacement is the definition for displacement. So the displacement, now this is the definition for displacement. Displacement is the shortest straight line distance between any 2 points in a specified direction. The displacement is the shortest straight line distance between any 2 points in a specified direction. So it's not like this. So it's the shortest straight line. So from starting point to end point, we don't have to start going round and round as in distance. With displacement, we just go locate the shortest straight line distance. So that's why we drew this line. So you see it forms a hypotenuse. It forms the hypotenuse of a right angle triangle. So the displacement is from A to C. So you can just find the length of okay, similarly, a ceiling fan. Let's say we assume a ceiling fan has already been set at to a particular speed. Now that ceiling fan is rotating at a constant speed, okay, but it has a changing velocity. Why? Because the velocity depends on both magnitude and direction. See, the direction is changing because it's moving, it's rotating. See, the arms of the blades of the ceiling fan are rotating, are constantly changing direction. So even though the speed of the fan is constant, the velocity is changing because direction is changing. All right, now let's look at the direction of, now look at this. With the magnitude of the man's displacement is 5 meters, but we need to find the direction. We want to find the direction in terms of angles. We know it's a northeast. This line is northeast, but let's get a particular angular bearing with respect to x. So we need to find theta with respect to the horizontal axis. That's how we find the direction of the displacement, the direction part of the displacement. So we can see, we can use SOHCAHTOA, that's TOA, because with opposite we are given the opposite and we're given the adjacent. Of course, you just extract this is opposite parallel to this and then that. So extract it.